Welcome to Custom Architectures. This lesson is part of Module 06, Advanced Topics. Let's get started. Let's now look at Lesson 6.5, Custom Architectures and Model Modifications. Here we can see the Mo architecture. Let's now look at Overview. Here we can see the custom attention. Go beyond standard fine-tuning by modifying the architecture itself. Learn to add custom layers, modify attention mechanisms, create adapters, and perform model surgery for specialized tasks. Perfect for research and highly specialized applications. Duration, 90 minutes. Difficulty, advanced, requires deep learning knowledge. Let's now look at learning objectives. Here we can see the architecture comparison. By the end of this lesson, you will understand when to modify architectures, add custom task-specific heads, modify attention mechanisms, create custom adapter layers, perform model surgery, layer removal, TOT addition, initialize new layers properly, achieve plus 10-30% task-specific improvements, task-specific. Let's now look at when to modify architectures. Here we can see the scaling laws. Let's now look at standard fine-tuning is enough when, here we can see the Mo routing diagram. Task is similar to chat instruction following general language understanding. Sufficient quality requirements are moderate, no special structure, tools, constraints needed. Stick with standard low-rank adaptation. Let's now look at architecture modification needed when, here we can see the rope scaling comparison. Highly specialized task, e.g. molecule generation, protein folding. Specific output structure required, e.g. JSON with validation. Domain has unique patterns, e.g. medical codes, legal citations. Need extreme efficiency, e.g. edge deployment. Research experimentation. Consider custom architectures. Let's now look at Technique 1, Custom Task Heads. Here we can see the architecture ablation. Let's now look at what are task heads. Task head, additional layers on top of base model for specific tasks. Examples, classification head, sentiment analysis, topic classification, regression head, score prediction, rating. Extraction head, named entity recognition, span extraction, generation head, constrained generation, structured output. Let's now look at example, sentiment classification head. Load base model, get hidden size, ISMO. As defined custom classification head, BASOR. Initialize properly, important. Benefits, fast training, only head, not full model. Efficient, 10-100x fewer parameters. Flexible, multiple heads for multiple tasks. Let's now look at Technique 2, adapter layers. Let's now look at what are adapters. Adapter, small bottleneck layers inserted between existing layers. Architecture. Here's the bash code for this section, starting with original. Benefits, more expressive than low-rank adaptation. Task-specific without modifying base. Can stack multiple adapters. More parameters than low-rank adaptation. Let's now look at implementing adapters. Initialize residual connection. Adapter pathway. Add residual. Insert adapter into model. Create adapter. Let's now look at Technique 3, modifying attention. Let's now look at sparse attention. Problem? Full attention is ON2, expensive for long sequences. Solution, sparse attention patterns. Local window attention, global attention for every 64th token, use in model applied during generation. Benefits, ON log n, or ON complexity. Can handle longer contexts, minimal quality loss. Let's now look at grouped query attention, already in Llama. Grouped query attention, fewer KV heads than Q heads. Here's the bash code for this section, starting with standard, 32 Q heads, 32 K heads, 32 V heads. Benefits, 4x less KV cache memory, 2x faster generation, minimal quality loss, already in Llama 3.2. You're using it. Let's now look at Technique 4, model surgery. Let's now look at surgery 1, layer removal, model compression. Remove layers, Update config. Remove last 3 layers, 32, 29 layers. Fine-tune to recover quality. Standard fine-tuning. Result, 90% size, 95% plus quality. Trade-off, 10% size reduction, net of 5% quality loss, acceptable for many use cases. Let's now look at surgery. 2. Layer addition, model expansion. Copy last layer as template, create new layer. Reinitialize weights, important. Add to model update config. Add 2 layers, 32, 34 layers. Trade-off. With 6% size increase, potential plus 5 to 10% quality on complex tasks. Let's now look at Technique 5, custom generation constraints. Let's now look at structured output, JSON. Add schema to prompt, generate extract, JSON. Find JSON in response, validate check schema. Let's now look at complete example, medical code classifier. Task, classify medical text, ICD-10 code, 10,000 possible codes. 1. Load base model. 2. Create custom head for 10K classes. Das von Sokin. Results. So 85 to 90% accuracy on medical code classification. Let's now look at architecture modification checklist. Here's the bash code for this section, starting with custom architecture checklist. Let's now look at key takeaways. 1. Only modify when necessary. Standard fine-tuning works 90% of the time. 2. Task heads, fast, efficient for classification, regression. 3. Adapters, more expressive than low-rank adaptation, stackable. 4. Attention modifications, handle longer contexts, improve efficiency. 5. Model surgery, compression or expansion for specialized needs. 6. Proper initialization, critical for new layers. 7. Always compare to baseline. Justify the complexity. Let's now look at what's next. Custom architectures mastered. Final lesson, production optimization. Continue to lesson 6.6, advanced optimization. Let's now look at additional resources. Adapter papers, sparse attention, grouped query attention, model compression survey, PyTorch model surgery. You can now architect models for any task. Time to optimize for production. That wraps up custom architectures. Well done on completing this lesson. See you in the next one.